Hello everyone, welcome back. Today in this video we'll be taking a bit of a look at a basic introduction to the derivative. So as we all know, the derivative is simply a derivative of a point of a point. The derivative of a function at a point, for example c, is simply just the gradient of that point. And how do we? So let's take a bit of a look at a formal definition before we go into the intuition. So given a function g of x, um, the derivative g prime of x is the slope or the gradient or the tangent of the graph at each point x in the domain. Okay, so the derivative just basically means the tangent, the slope of the tangent at a particular point. So for example, the derivative of a point c on the domain is simply the slope of this yellow tangent. What's the gradient of this yellow tangent at that point c? So how do we compute this derivative, or how do we know that the derivative of a function exists? Well, for that we use this crucial definition of the derivative involving limits again. So the derivative of a point g prime of c is simply the limit of this g of x minus g of c over x minus c as x approaches that point c where we're seeking the derivative of. So consider again this graph which I drew on the right. So we want the derivative of the point c. That is, we want the slope of this tangent line to the graph at this point c. So what we do is we consider this tangent line, any arbitrary tangent line, which has which has the gradient g of x minus g of c over x minus c. Well, this is just the definition of the gradient, as we all know. So the gradient between the point c and x is g of x minus g of c over x minus c. Now what we'll do is we'll consider the gradient as x approaches c. That's what this limit is saying over here. Limit as x approaches c. So we consider this tangent. Just watch this white tangent as it moves towards a yellow tangent. It becomes more and more flat as x approaches c, and finally it becomes this yellow tangent that we're actually seeking for. So that's simply the definition of a derivative. There's nothing much else for it. This simple definition gives us a lot of many useful facts. We'll see the derivative again in integration, and the derivative is crucial in many machine learning and deep learning optimization criterions. So let's consider example first. This is a very famous example that you'll see in many analysis textbooks. So let's see gn of x is xn of sine of x, where this n can represent, for example, if it's g2, over here it'll be x squared, something like that, and sine 1 over x when x is not equal to 0, and 0 when x is equal to 0. So let's consider g1 first. G1 of x, which is x sine 1 by x when x not equal to 0, and 0 when x equals to 0. So let's consider the derivative of this, and let's see if it exists at the point x equals to 0 using the limit definition above. So that simply is g1 of x, the g1 prime of x. Okay, we want at point 0 at 0. So g1 prime of at 0 is simply the limit as x approaches 0 of g1 of x. So remember, I'll quickly do the definition again. Limit as x approaches 0, g1 of x minus g1 of 0 over x minus 0. This is because we want the derivative at 0. We want to see if the derivative exists at the point x equals to 0. So this is g1 of x is simply x sine 1 by x minus, and g1 of 0 is just 0 because of when you substitute 0 over here, it just multiplies out to get 0 over x minus 0. and this simplifies to sine 1 by x. So if the derivative exists, then this limit as x approaches 0 of sine 1 by x should exist. But this is a famous function for those of you who haven't seen it yet. So this function oscillates wildly at 0. It has some mad fluctuations there at 0. So what happens is at x equals to 0, this limit does not exist. So since this limit does not exist as x approaches 0, we can say that g1 prime of 0 is undefined. That is, there is no derivative of g1 at the point x equals to 0. So let's again now consider g2. So g2 of x is simply x squared sine 1 by x and then 0. So let's see if the derivative exists for g2 of x. Okay, so we'll again follow the same template. We'll ask for, let's go for a bit of a different color there. Limit as x approaches 0 of x squared sine 1 by x minus 0 over x minus 0, and this, so remember this is g2, sorry, this is g2 prime of 0, that is this. So this simplifies to x sine 1 by x, and now the limit as x approaches 0 of x sine 1 by x, 1 over x. Okay, again, so this is g2 prime of 0. This limit exists as when we substitute x as for 0 for x over here, we simply get 0. So this limit exists, and therefore since this limit exists, from our definition we get that g2 prime of 0 exists. So the function g2 is differentiable at x equals to 0. In fact, g2 is differentiable everywhere in the domain. Let's just differentiate this function by chain rule. We simply get 2x sine 1 by x, and the other term we get minus cos 1 by x and 0. So this function is differentiable everywhere. So one more important thing before we wind up this video is, let's see if this g2 prime, this is g2 prime, remember, let's see if this g2 prime is continuous. We know that g2 is continuous at x equals to 0. We also know it is differentiable. It's differentiable at x equals to 0. So now let's see if g2 prime is continuous at x equals to 0. So for that we have to take limit as x approaches 0 of this g2 prime. But notice this cos 1 over x, this function right here, it's again the troublemaker. It also has wild mad fluctuations at x equals to 0, and the limit does not exist. So the limit of g2 prime of 0 does not exist, and therefore this is an interesting property we have just seen here. To summarize, the function g2x is continuous and differentiable at x equals to 0, but the derivative function g2 prime of 0 is defined everywhere on R, because we have it right here, it's defined everywhere on R, but it has a discontinuity at 0. So this is an interesting point we have seen here. The conclusion is that the derivatives themselves, even though g2 is continuous and it's differentiable at x equals to 0, the derivatives themselves don't need to be continuous. So I hope you enjoyed this video. Next video we'll be talking about the intermediate value theorem and the derivatives. See you then.